and the sum is out of a circle of radius r equals in centimeters. Substance a right angle at this center. Find the area of the corresponding. You need to remove the area of your minor segment as well as you need to remove the area of your major segment. So this is clear. So let me draw it a circle with a center O as well as it is subtending an angle of 90 degrees. This is clear. And this is your 10 centimeters of radius. Both the sides, and this is your O. And he also says that there is a minus segment. So this region is your minus segment. Given over here, the angle subtended, whatever the angle is made here, that is the angle subtended by the chord is 90 degrees. So this is clear. After that, the radius of your circle given as 10 centimeters. So clear. So let us look at this one now. We need to remove the area of minor segment. So first bit, let me remove the area of the minor segment. Area of minor segment. Area of minor segment given as this is equivalent to your area of the sector. Area of this sector. Area of sector POQ minus area of the triangle PO and Q. So this is also clear. So let us solve this one now. First of all, we need to remove the area of the sector. That is, area of the sector is equivalent to area of this sector is given as x by 360 into pi r square minus area of the angle half into base into your height. So the angle is your x, that is 90 degrees by 360 into, I am substituting the pi value given over here. Okay, into your r square is n into n again minus half into base is n and the height is also n. So this is removed out like this, and this 0 and this is removed out 9 1 and 4. This is reduced as half, and again this is reduced to half, and again this is also reduced to your half. Okay, so at last I have left over only 3.14 into 25 minus 50. Hope this is clear. Now when I'm doing this one into here, right, the resultant is 78.5 minus 50. So if I subtract this 2 here, so let us look at the second bit. The second bit is we need to remove the area of major sector. To remove the area of major segment, that is the major segment, is equals to, we need to remove the area of the circle minus area of minor segment. So this is clear. Area of minor segment. So this is area of a circle is pi into r square. R value is n into n. Area which we received as of now is this much. Now doing all this into, we are left with only this value. Now on simplifying this one also, I have left with this value, isn't it? So this is your required answer. Okay, let us look at the next sum over here. Take chord of a circle. Okay, let me draw a circle first, and it is having some chord. Okay, substance an angle of 120 degrees at this center. So the center angle is given as 100. Here, this is 120 degrees. Find the area of the corresponding minus segment of this circle. Okay, we should be removing the area of the segment of this circle. So first of all, the radius is how much? 12 centimeters. So this is here, and let me remove this. What would be the angle of M here? It should be 90 degrees exactly. Right. So let's solve this one. How do we solve this? First of all, let me remove the area of the sector first. Okay. So what do we require is we require the area of minor sector, isn't it? So let me write it over here. We require what area of the minor sector. Area of that is your minus segment is equivalent to area of sector, that is area of sector minus area of triangle, area of the triangle. Okay. So this is given. Let me name the triangle as O, C and Q. So the triangle area comes out O, C and Q. Okay. So I think this is clear up to here, right? So let us remove the area of the sector first. What would be the area of the sector first? So now I'm solving here the area of the sector. Area of the sector is equivalent to x degrees, right? So x is we were given this one 360 into I r 12. So what would be the value of x? The value of x is nothing but 120. Hope this is clear, right? 360 into I value is given over here into 12 into 12. Hope this is clear. So 0 is removed out. This is cancelled out one times and three times. And eventually this is also removed out. So we are left with only what? We are left with 3.14 into that would be your 48. Okay. So when I'm doing these two into the resultant is how much? This much. I hope this is also clear to everyone, right? So let us remove the area of the angle now. If you know that the area of the angle is half into base into height, isn't it? So let us remove this one, the area of the triangle. Let me write it over here. Area of triangle. That is your half into base is your EM and this is your OM, right? As you're having two different angles, as you can do here into two. So this would be eventually we will be getting this 2 into half into AM into OM, right? So this 2 and this 2 is removed directly without any issues, right? So let us remove the value of AM and this one. Okay. So to remove the value of AM, I'm using cos 30 degrees is equals to AM by OP. The value of cos 30 is root 3 by 2 em by the value of OP is given already. I'm keeping this one here. So I would be getting root 2 by 2 into 12 equal to em. Yeah, I think I wrote this one down. So this is your 2 and this is your 2. So this is your 6. Okay, so em value came out to be 6 root 3. Okay, so let me substitute here the value of am 6 root 3 into OM. I need to remove, I'm removing the OM value here. Okay, so value of OM I will be using here sine 30 degrees is equals to OM right OP, as you all know that. So the value of sine 30 is equals to half into OM right. Well, now I'm doing a cross multiplication. OM is came out to be 12 by 2. So this implies that OM is equivalent to 6, right? So simple, I'm substituting the value over here. Now doing 6 into 6 is 36 into root 3 is given as 1.32, isn't it? Now when I do this one out, the overall resultant comes out to be 62.352 centimeter square. Hope this is also clear. So at last, what do we require here? At last, what is needed here is that we need to remove the area of the minor sector, isn't it? So how do we remove the area of the minor sector? The area of the minor sector, let me write it here, area of minor sector or else your segment, I should not say sector, it is a segment is equals to area of this sector that is 150.72 minus area of the angle that is 62.352. So when I am doing these two subtraction, the resultant is 88.368 centimeters square. I hope this is also clear to everyone. Let's look at the next one over here. X R right for 25 centimeters. So the blade length is how much? 25 centimeters. Okay. And each of them swiping an angle of 115 degrees. Okay. Now you need to remove the total area cleaned at each sweep of the blade. So that is total area swept. Total area swept by two blades is nothing but 2 into the area of the sector, or else I can write that like this, area of the sector with radius, right? So let me write this, area of this sector with r equivalent to 25 centimeters, and the angle is equals to 115 degrees. So that is nothing but x by 360 into 5r square. I am taking the x value as, if I am adding out 115, the total value is how much? It's around 230. So I'm just substituting that one over here. I value came out to be 22 by 7. R value is 25 into 25. Hope this is clear. 0 is removed out here directly. So what is left out? If 2 0 is removed out, we need to 1,255 centimeters square. I hope this is also clear to everyone. See, this is your 625, right? This is your 625. We need to solve this one out. This cancels out 11 times. This comes out to be how much? 18. Okay, I hope this is clear. Up to here, it's clear, right? So, doing these two into and solving this one here, we will have this answer directly. Right? So, you can do this in your rough sheets. It's not a big deal, right? So, let's look at the fourth one here. Find the area of the shaded region in the figure where ABCD is the size of the square with 10 centimeters. And semicircles are drawn with each side of the square as your diameter. Hope this is also clear. So what I'll do here is, you need to remove the marker region, right? So you need to remove this region, shade region. So let me mark this one as 1, this one as 2, this one has 3, and eventually this one has 4. Hope this is clear, right? So what I do is, we will be adding up everything. That is, let me remove first the area of 1 plus 2. Okay, so that is nothing but, if I look at 1, that is area of ABCD, that's your square, minus area of two semicircles, right? Area of two semicircles with r is equal to 5 centimeters. So this is clear. So the area of a semicircle is 10 into 10 minus 2, as I'm having two semicircles. Semicircle is half of I value, that is your 22 by 7, 22 by 7 into, what is that? It is your r value 5 into 5. 5 into 5. Oh, this is clear. So this is removed out like this to this is removed out simply, right? So when I do this one out, I'm having here 100. The other one is 22 by 7 into 30. I am getting here. Okay, this is not that way. This is 25. So this is clear. Up to here, this one out with this, right? So when I'm substituting the value of this one, this comes out to be 100 minus 3.14 into 25. Now, if you do this in your rough books, in the rough area, the resultant is 78.5. Now, if you're solving this is 21.5 centimeter square. So this is clear, right? Similarly, we will be removing the area of 2 and 3. Okay. So similarly, area of 2 and 3. So eventually what happens is, wait, we'll be removing the area of 2 and I think, yeah, 2 and 4. Here it is 3, it is not 2, it is 3. So because it's your opposite, whatever the balance remains the same thing. Okay, 2 and 3, 2 and 2 and 4. I think I wrote it there wrong, right? So this value would also be 21.5 centimeters square only, right? So eventually, what is the shaded region? Therefore, the shaded region we need to remove, right? The shaded region is nothing but the overall area of triangle of the square ABCD minus the area of unshaded region. Area of unshaded region. We have removed the area of unshaded region only. So here I can write it as 100 minus 2 as I am having double of it, right? 2 into 21.5. So this is 100 minus 43. So at last the resultant is 47 centimeters square. Hope this is also clear to everyone. Let us look at the next one. That is your fifth one, right? So find the area of the shaded region in the figure. If ABC is a square of size 7 meters and ABC, okay, these are your semicircles. Hope the question is clear, right? See, area of the shaded region. We'll do it in a singular way. Area of shaded region. Area of the shaded region is equals to area of the square. Area of the square ABD minus area of two semicircles. Area of two semicircles. Hope this is clear up to here, right? So let us do this one. Area of the square is your eccentrics, that is 7 into 7 minus area of two semicircles. So I'm writing a 2 into half into I value is 22 by 7 into half of the radius is this much. Isn't it? I hope this is clear to everyone. Here, when I'm solving this one and this one is removed out, this can be written as how much is 0.5 directly. So I can write this as 49 minus, when I'm doing these two into, I have left with only 11 into 35. Now, when I'm doing here this 10.5 centimeter square, this is your area of shaded region. This is area of the shaded region. Hope this is also clear to everyone. Now, in the sixth sum, let us look into the sixth sum. Hope this is also easy. In the figure AB, YSAB is a quadrant of a circle with center O. Okay, and radius R. OD is also given over here. That's your 2 centimeters. So this is clear. And if you all know that this is your angle of 90 degrees directly. Now he is asking us to remove the area of the shaded region. Hope this is clear. So let me solve this directly. That is area of the shaded region. Area of the shaded region is equivalent to area of center. P clearly, right? So area of a sector is x by 360 into pi r square minus half into base is your OB in, and your height is OD. Hope this is clear. So x value is 90 degrees by 360. Pi value is taken as 22 by 7. R value is 3.5 into 3.5 minus half into OB is 3.5. OD is how much? 2 centimeters. This two and this two is removed out directly. 0, 0 removed out, 9 ones are, this comes out to 4s are, this is half of this, so this becomes your 11. I hope this is clear up to here, right? 4s are, that comes out, that, yeah, so this is your remember, and I can remove this one as 0.5 directly, right? So when I'm solving this one out, I have left over only 9.625 minus 3.5. Isn't this clear? So when I subtract this, I can write this one directly as like this. So this is your area of the shaded region. Hope this is clear to everyone. Let's look at the next one here. So AB and CD are respectively two arcs of a concentric circles of radii. You have two different radii with this same center O. If O is how much? It is around 30 degrees. This is how much? This is around 30 degrees. And the area of the shaded region. Hope this is also clear to everyone. Let's do this one directly. Area of the shaded region. Area of the shaded region is equivalent to, I can write here as the area of OAB, that is sector, right, minus area of OC and D. That is, I can write here the angle as 30 by 360 into 22 by 7 into the value of R of the above one is 21 minus area of the sector of the next one, that is 360 into 22 by 7 into 7 into 7. Hope this is clear up to here, right? So here what I'll do is I'm removing it out 30 by 360 and 22 by 7 outside. Now these two into, when you are doing 21 into 21, the answer what we are getting here is 441. Hope this is clear. And 7 into 7 is how much? 49. So substituting that one here, 441 minus 49, right? So here 0, 1, 0, 0 removed out, 3 ones are 102 is removed out here directly. Half of this and again half of this, right? So eventually I can write this one as 11 by 42. Now subtraction of 441 and 49 gives us to be, so 441 and 49, if you're subtracting this one, we are left with here with 3, and this is 3 and this is your 9. I hope this is clear. Yeah, I think this is 2, right? Yeah, 2. So this is 392. Okay. Now by solving this one, I would be getting 0.66 centimeter square, which is your area of the shaded region. If you want me to solve this, I can do this like this, right? 392 divided by 42. So this is clear. So 42 into height. Doing this is 21. So 42 into 6 is your 12, 24 and 25. 42 into 7 comes out to be how much? 14, 28 and 29. So I think they're almost there, right? Let's look at it 9, 18, 36 and 37, right? So this would be your answer. So 9s are up to 378. This comes out 8. This goes out one time. This comes out to be how much? 4 times, right? Now keeping in decimal here and 0 here, you are having 140. So 42 into 4 gives us how much? 168. 42 into 3 gives us how much? 126. So this is here 3. So 93 into 11, 9.3 into 11, you will be having the answer approximately right? So let's look at the next one. Now I'll get the area of the designed region in a figure. Okay, common between the two quadrants of the circles of radius 10 centimeters each. Okay, what I will do here is I will add two sub points here. That is, I am directly marking 2 points here. That is P and Q on either arcs. On the either arcs. So this is clear on either arcs. Okay, and BD be the diagonal. So I'm writing here Q and I'm writing here P here. Okay, and B to D as diagonal. I hope this is also clear. Okay, very good. So let us look at the next one. Now area of the area of the required segment. That is, let me write here area of required segment. Area of the required segment, that is D and B, the required arc, is equivalent to area of sector minus the sector area is A, D, C and B minus area of triangle A, B and D. Hope this is clear. So I can write this as x by 360 into pi r square minus half into base into and again height. Hope this is also clear. Right? So x value is taken as 90 by 360 into 22 by 7 as the value, right, into r value is n into 10 minus 20 into the base and height value is substituted. So this comes out to be minus 50 here. 0, 0 remove 1s are 4 are half of this and half of this, so comes out to be what? 11, right? Now 2 is divided how many times? 5 times. Now this is 55 by 7 into 10. Now by solving these two here, we are left with I am left with only 78.57 minus 50 is equivalent to how much? 78.5 centimeter square. Now, this is the area of only one side, that is only this side. Right now, you need to remove the area of this side also. If we have removed the area of this side, now I'm removing the area of the other side, right? So therefore, I'm writing at the top here total area, total shaded region. Total shaded region is, let me write it, dpb plus dq and p. Now adding up these two, that is, these are the different segments. Now adding up these two, 28.5 plus 28.5. Now